Hello learners, welcome to the program of National Institute of Open Schooling Noida. I am Dr. Arun Kumar Gupta, Academic Officer Physics.
And I am Seth Singh, Principal Navigo School, Lodhi Colony, New Delhi.
Learners, today we will discuss on the topic wave optics and its application.
Learners, you will be interested in knowing that what is wave. And wave is a periodic disturbance carrying energy from one place to another place. About the nature and theory of wave, so many concepts came in existence, but the Huygens theory and Fresnel's wave theory are very important, which we are going to discuss today. It is convenient to picture a wave in terms of wave front. Wave front is the locus of points which vibrate in same phase. Although the wave front may be drawn for any phase, but it is customary to a few of them corresponding to the maxima and minima of disturbance. So, here we can see in the diagram the different types of wave front. In first diagram, the wave is coming from the focal point of a lens, and after refraction from the lens it becomes parallel beam of light, hence the wave front form is plane wave front. In second diagram, we can see this wave front after refraction of the lens becomes the cylindrical wave front. So, we can have three types of wave fronts here. One is plane, one is cylindrical, and one more is spherical. It is very important to know about the wave front that a point source of light emits a spherical wave front of light, and arrangement of point sources of light kept at the focus of a convex lens gives parallel beam of light, hence the plane wave front as you have seen in the diagram. A slit illuminated with a parallel beam of monochromatic light gives cylindrical wave fronts, but a line illuminated with a parallel beam of monochromatic light gives cylindrical wave front. At the same time, you must understand that a line source of light will not give a cylindrical wave front. This is because all points of a line source do not emit light waves in the same phase.
How the concept of wave does came in existence, sir?
According to Huygens and Fresnel, here we have to discuss first the postulates of wave theory, and according to these postulates, in order to investigate the progress of a given wave front, Huygens give a geometrical methods. So, we know these methods as postulates of wave theory, and according to this wave theory, every point on a wave front acts as a source of secondary waves, that is known as wavelets. The position of new wave front we can obtain by drawing an envelope of radius c into t, where c is the velocity of light and t is time. The direction of wave propagation is always normal to the direction of wave front. So, these are certain postulates, and on the basis of these postulates we can relate some daily life phenomena by having the properties. And first property of light, which is very common and popular, is reflection of light. So, here you can see AB is the incident wave front and A dash B dash is the reflected wave front. Point P and Q are the points on the same wave front. Point P is on incident wave front and Q is on reflected wave front. Here angle I is angle of incidence and angle R is angle of reflection, and N1 and N2 are the normals. M1P and M2Q are the wave fronts at the time of incidence and at the time of reflection. So, in this diagram you can take two triangles, and that is M1P M2 and M2Q M1, to prove angle I is equal to angle R, that is angle of incidence is equal to angle of reflection. But important point of application is, since point P and Q are the points of same wave front, that is why light takes same time to travel from point P to M2 as it takes time to travel from M1 to Q. That is why in same medium with equal velocity of light, distances are equal. So, we apply here the Huygens wave postulates and we can say that these two triangles are similar, in which angle of incidence is equal to angle of reflection. One important point is also to see that the incident wave, reflected wave and normal drawn at the point of incidence all lies in the same plane. So, these 2 points are called the laws of reflection. Similarly, we can have refraction also. In refraction, light travels from one medium to another medium. Again, AB is the incident wave front and it is refracting into the second media, which has given a small shade. I is the angle of incidence and R is the angle of refraction here. Point P and Q are the points on incident wave front and refracted wave front. Again, here is an important point that the P and Q are the points of same wave front, but the medium is different. So, light does not travel same distance from point P to M2 and from point M1 to Q. That is why these two distances are not equal. So, here we apply the different theory to calculate sine of angle I and sine of angle R in terms of these distances. Since velocity of light is common and constant in a one particular medium, so for the same time their ratio also remains constant, and this ratio is known as refractive index of the second medium in which light is passing with respect to the first medium, and we can write it as symbol n 1 2, that is sin I upon sin R. Again, in this case the incident wave, refracted wave and normal drawn are in the same plane, and this sin I upon sin R, which is equal to refractive index, is also known as Snell's law.
Sir, our learner wants to know which physical quantity changes and which does not change during reflection and refraction.
This is a very important question, and to know about it, in reflection, since there is no change in the medium, so the velocity, frequency and the wavelength remain constant. But in case of refraction, since there is a change in medium, hence the velocity changes and correspondingly the wavelength changes, but frequency remains constant, and color is the function of frequency. So, during refraction again there is no change in the color also. Now, we can take one more property of wave, that is interference of light. You must know that there is a very interesting line, light added to light makes dark. So, this complicated phenomena in life can be explained on the basis of interference of light. When two or more waves coming from coherent sources of light and they superimpose in a medium, the redistribution of energy takes place, and this phenomena is called interference. That two waves of amplitude A1 and A2 having a phase difference of phi are superimposed, then there is a resultant wave of amplitude, that is A is equal to A1 square plus A2 square plus 2A1 A2 cos phi and its under root. Since intensity is directly proportional to square of amplitude, therefore, this result can also be expressed in terms of intensity, that is I is equal to I1 plus I2 plus 2 under root I1 I2 and cos phi. For phi is equal to 2 n pi, the intensity will be maximum, and for phi is equal to 2 n plus 1 pi, intensity will be minimum, where n can have any value 0, 1, 2, 3 and so on. So, we can find the ratio of maximum and minimum intensity in terms of intensity and in terms of amplitude. Here in interference different types of fringes are formed, and the visibility of the fringe can also be given as V is equal to I maxima minus I minima divided by I maxima plus I minima.
Sir, can all source of light produce interference?
No, that interference will not be the sustained interference. So, to have sustained interference, we should understand the sources required must be coherent, and the ordinary source of light do not produce interference because every natural source of light emits light pulses, for a very short interval of time, and this interval of time may be 10 raised to the power minus 8 second and so. So, there is no control over the intensity or over the instant at which an individual atom emits a light pulses, and no stable phase relationship exists between the light pulses emitted independently by two sources of light. That is why we need the constant phase change with time, and the value of phi changes with time, then there is an equal probability of positive and negative value of cos phi. In fact, the time average value of cos phi becomes 0, and then the resultant intensity at the screen is given as I is equal to I1 plus I2. If sources are coherent, the maxima and minima distribution of energy takes place, that is interference. If sources are not coherent, then intensity will be the algebraic sum just I1 plus I2, and it is not the interference. To get interference experimentally, there is one experiment, popular experiment, double slit interference, Young's experiment, and this experiment is designed by Thomas Young. Here one source is divided into two sources, and these two sources are coherent sources. These two sources are obtained by putting two slits S1 and S2, and the light coming from S1 and S2 gets superimposed at the screen placed at the distance capital D, and here the slit separation is small d. So, again we can calculate phase difference between the light coming from S1 and S2 either in terms of phase or in terms of path difference. Then we can put the condition, if this path difference or phase difference is according to the initial condition of 2n pi or 2n plus 1 pi, we will get maxima and minima, and these fringes can be obtained. We can show with the experiment, and this experiment is a very small experiment. I have a laser torch, and you can see the impression of this laser torch on the screen here. It is a green laser, and we have a double slit here, and when I put this double slit here and it is illuminated with the laser torch, you can see on the screen a fringe pattern. Now, you have seen in this experiment different fringes are formed, and mathematically this fringe width can be given as lambda d upon d, where d is the separation of the slits and capital D is the distance of the screen and lambda is the wavelength of light. And something more you must know about these fringes, dark fringes. Dark fringes are nth and n plus 1th dark fringes are observed at position xm and xm plus 1. Then we can calculate the fringe width of dark fringes also. So, the fringe width of dark fringe is again lambda d upon d. It means dark and bright fringes are alternatively taking place on the screen. Similarly, regarding the distribution of intensity distribution you can express as I1 plus I2 plus 2 under root I1 I2 cos theta, where theta is the phase difference and it can be given in terms of path difference also. So, this is 2 pi lambda into path difference, that is 2 pi lambda, and path difference we have already seen x d upon d. So, the intensity can also be expressed in terms of this path difference, that is I1 plus I2 plus 2 under root I1 I2 cos, in place of theta we can write 2 pi by lambda into the path difference. Here this triangle indicates the path difference. And now we can have certain problems related to the phenomena. If we take one of the slit of the double slit system is wider than the other, so that the amplitude of the light reaching the central part of the screen from one slit acting alone is twice that from the other slit acting alone. So, now we can derive an expression for the intensity distribution of this type of problem. So, let us look at the solution using the standard result of intensity which you have just seen, let us take two sources of amplitude A1 and A2 and phase difference of theta, then we can write the value of A1 and A2 and then we can calculate that intensity is given as I upon 9 multiplied by 1 plus 8 cos square pi by lambda xd upon d. It is
Sir,
a very simple mathematics which we are explained here.
Sir, is there any similar phenomena?
Yes, one more important phenomena that is very interesting is the diffraction of light. And what happens in diffraction of light? When light passing through a narrow slit or a small aperture or close to the edge of an opaque object, it is found that it bends around the corners, and the effect associated with this bending of light is known as diffraction. The simplest case of diffraction occurs when a narrow slit is illuminated normally by a plain monochromatic light waves as shown in the diagram. Here you can see in the diagram that the light is coming and it is passing through a narrow slit, and redistribution of energy again you can see on the screen. And how this specifically the intensity is changing? It is a very beautiful and complicated phenomena. Intensity falls down extremely small. On the screen you can see the peaks of the intensity, and by a very small experiment we can also show the similar phenomena of diffraction by taking a single slit here and the laser torch. When this slit is illuminated, you can see the beautiful phenomena on the screen and how this intensity is changing. So, this is a very small experiment in which you can see the fringe pattern of diffraction pattern, and now we are interested to know about the intensity of light leaving the slit and travelling in a direction that makes an angle theta with the incoming light. The light is ultimately focused at the point P on the screen by using a lens. Let us divide the slit within a very small numbers, and let me say 2n, where n can have any value 1, 2, 3, 4, 5. These wavelets coming from the different parts of opening interference in such a way that maximum and minimum are produced in different directions. If the obstruction is made at P naught in the direction theta is equal to 0, we find that the wavelets from all parts of the slit reach there in phase so that a maxima is obtained there. If theta is gradually increased, the wavelets reaching at P will get out of phase in order to find the position of first minima, and we observe that a path difference Bn between the wavelets coming from A and B is lambda. The path difference OM between the wavelets coming from A and from the center O is lambda by 2. Thus, the first part of the slit would interfere and no light would be obtained on the direction theta, such that Bn is equal to lambda. If we take slit width A, then Vn will be A sin theta, and the condition for first minima is A sin theta is lambda, where A is the slit width and position of other minima are given as A sin theta n is equal to n lambda, where nth is the order of minima.
Sir, is there any effect on the fringe pattern if slit width decreases or wavelength changes?
Yes, definitely, because in the expression we have seen that the fringe width related to the slit width. So, if slit width changes, the fringe width also changes, and lambda is also coming in the formula. So, slit width and lambda both are related to the fringe width. With the change in lambda, fringe width will also change, and there is very one important point which is to be kept in mind. If slit width is very large, no phenomena of interference and diffraction takes place. If slit width is very small, again no phenomena of interference and diffraction takes place, because for larger slit width it will be a very small fringe width which is not noticeable. For a very small slit width, the fringe width will be so large, it will not show you the fringe pattern. And here similarly we can see the number of diffraction pattern in different wavelengths. Let me take the wavelength of red color light and blue color light. So, the fringe width of red color light and blue color light will be different, and their maxima will be different. And one more important point about the diffraction pattern is, order of the wavelength of light must be in the order of the slit width, then a beautiful pattern of diffraction takes place. And this phenomena of diffraction is applicable while we are deciding the resolving power of microscope and telescope. And similar phenomena you can see with the help of different multiple slits. So, here we can show you the multiple slit, and again with the help of laser light and the phenomena which you can see on the screen. So, how this diffraction and interference are related, and they are applicable in all these optical instruments. It has many application, and diffraction gratings, and making the lens of high resolving power, of considerably adequate resolving power, telescope making, and other optical instruments. So, now you have learned about the wave optics and its few of the applications.
Sir, in between talk you have talked about monochromatic light. So, what is monochromatic light?
And it is very simple to know that mono means a single and chromatic means the color. So, single color, or you can say the single wavelength light is monochromatic light, and the light of different color and several color, and you have already have seen in the films that it is Eastman color film, like that. So, monochromatic means single color or single wavelength light.
At our home we are uses tube lights. Is this monochromatic light?
Not at all, not at all. Apparently it looks in color as a single color, but if you see at the spectrum of that, it is varying from some smaller value to some larger value. So, it is not monochromatic, it is not single wavelength light.
Thank you, sir. You came in this program and discuss much in detail about wave optics and its application. I think our learner is now more clear about what is wave theory and related phenomena. Thank you, sir, and I think such type of program will continue, which will be fruitful for our learners. Thank you.
Welcome.
जीवन ये प्रकाशित करने राहों को आलोकित करने,
जीवन ये प्रकाशित करने राहों को आलोकित करने, हम अपना दीपक स्वयं बने, हम अपना रास्ता स्वयं चुने, हम
अपना दीपक स्वयं बने, हम अपना रास्ता स्वयं चुने।
जीवन ये प्रकाशित करने राहों को आलोकित करने।
धन साधन समय की सीमा से विद्यालय जो मुक्त हो,
कभी पढ़े हम कहीं पढ़े, वे विषय की लोच से युक्त हो।
कभी पढ़े हम कहीं पढ़े, वे विषय की लोच से युक्त हो।
मित्रों हम उठे और जागे,
मंजिल आने की ध्वनि सुने हम, अपना जीवन स्वयं बने हम, अपना रास्ता स्वयं चुने।
जीवन ये प्रकाशित करने, राहों को आलोकित करने।
राष्ट्रीय मुक्त विद्यालय का है द्वार खुला सबकी खातिर।
शिक्षा परीक्षा का अवसर एक बार ही क्यों मिलता फिर।
शिक्षा और परीक्षा का अवसर एक बार ही क्यों मिलता फिर। दुनिया में इसके केंद्र बहुत,
कोई मन चाहा केंद्र चुने हम, अपना जीवन स्वयं बने हम, अपना रास्ता स्वयं चुने। कोई मन चाहा केंद्र चुने हम, स्वयं बने हम,
हिंदुस्तान के हर कोने में नौजवानों के पास प्रतिभा है, उन्हें अवसर चाहिए।
NIOS देता रहा है युवाओं को अवसर आगे बढ़ने का। NIOS से पढ़ने वाले इन युवाओं ने किया है संस्थान को गौरवान्वित। दिव्यांगों ने बन के दिखाया है सबल और आत्मनिर्भर। NIOS के साथ आप भी जुड़िए NIOS के संग।